Welcome to the Payy Smart Contract Security Audit conducted by AuditOne. Payy is a platform designed to facilitate self-sovereign banking through cryptocurrency, offering a simplified and secure approach to the financial services traditionally managed by banks. The platform integrates a zk-rollup tailored for applications requiring privacy and scalability in payments and decentralized finance. Payy smart contracts were audited between June 25 and July 2, 2024 by Eugenio Clars, Ubermensch 3.0, and AuditOne. The audit finished with the following scores: security score, 100%, documentation quality, 98%, code quality, 97%. Let's review the issues identified in Payy smart contracts. Burn-to-pool and mint-from-prement calls can be replayed. Signatures or messages should be tracked in the smart contract in order to guarantee they are not submitted multiple times. Another approach to mitigate this risk is nonce-based replay protection. This ensures each transaction can only be processed once. This will also prevent replay attacks and ensure the secure execution of the burn-to-pool and mint-from-prement functions. Stale liquidity index usage in Rollup v5. Before using the liquidity index function to calculate the USDC amount, call the update index function to ensure the liquidity index is up to date. This will ensure accurate calculation of the USDC amount for withdrawal. Potential withdrawal failures due to AAVE rounding. To mitigate this issue, it is recommended that the potential precision loss in the contract's logic be accounted for. One approach could be to cut a small buffer amount, say 1 way of the token, from the withdrawal requests. This ensures the user can withdraw the expected amount even after rounding, avoiding temporary locking of the user's funds. Griefing and denial of service attacks abusing the USDC blacklist. Implement a check within the burn-to-address function to verify if the target address is blacklisted. If the address is blacklisted, review what to do with the USDC. You could skip this transaction or send the amount to a treasury and decide later what to do with it. Malleable signatures. It's recommended to implement a check to verify whether the signature used as an argument is above half the curve order. Incorrect rounding direction results in protocol insolvency. To ensure the protocol remains solvent, it is recommended to round up the shares to be burned from the user's balance. This way, the protocol always retains enough funds to fulfill users' withdrawal requests. It's also mandatory to adjust the rollup contract accordingly to avoid locking the user's funds for not having enough shares to fulfill the withdrawals. Burn-to-pool calls can fail if the AAVE pool supply cap is reached. To prevent burn-to-pool calls from failing, it is recommended to either implement a cap on the burn-to-pool amounts or check the AAVE pool supply cap before submitting the proof on-chain. Valid after and valid before arguments are not checked in the mint-from-pool with authorization function. Add the following require statements to ensure the function is only executed within the valid time frame. Recommend using ownable two-step upgradable instead of ownable upgradable. Replace ownable upgradable with ownable two-step upgradable to utilize the enhanced security features of a two-step ownership transfer process. Unsafe type conversions can lead to overflows. To mitigate the risk of overflows, it is recommended to use safe casting methods available in libraries such as OpenZeppelin's SafeCast. This ensures that type conversions are performed safely, preventing potential overflow issues. Lack of sanity checks in signature usage. It is recommended to implement some validations for input signatures. For example, using OpenZeppelin wrappers for EK-Recover, since it implements several checks in order to guarantee all parameters from signatures are correct. Replay attack due to cached domain separator in EIP 712 implementation. Update the EIP 712 implementation to dynamically include the current chain ID returned by the chainid opcode in the domain separator calculation. Adhere to the best practices of the EIP 712 implementation. We're pleased to reveal that Payy's smart contracts have been fortified following our thorough security review. The Payy team has expertly resolved all critical issues and minimized risks. For a closer look at the findings, read our comprehensive report. AuditOne, your trusted partner in blockchain security.